Hi guys, today I want to talk about Lovas Local Lemma, and if you I want to show you the first part. This is the definition. So let's say we have n bad events, so AI's are the bad events, and say probability of one bad event is P, and say all those bad events depend on D number of bad events. For example, some bad event AI depends on D number of bad events. Then if this expression holds, then there is a probability that is greater than 0 in which no bad event occurs. That means only good event occurs. So neither of A1 to AN happens, and the probability is greater than 0. So for this to happen, this expression should hold. This is what Lovas Local Lemma does, and we want to show one example for this lemma. So let's say we have n different colors. Okay, we have n different colors, and there is a circle, and there are n such kind of points. There are n different 11 n such kind of points. We have 11 n points, and we have to put 11 points for each circle, so for each color. So each color takes 11 points, so n different color takes 11 n different points. Then what we have to show is there must be a set of n points, containing 1 point from each color. So in that set, for example, so let's say it's point P1, P2, P3 to Pn. Each of these points should be of different color, and next and the next condition is there should not be pair of adjacent points. For example, they should not be like this. So in this set, it should not be this I, and it should not be I plus 1. So for example, if this is I, then this can't be I plus 1, or any of the points can't be I plus 1. So they should not be adjacent. Okay, so how we prove this is, so let's say we first pick up a point of each color at random. For example, we just choose A and put it here, B, not B. For example, then we choose this point, put it here, we choose this point, put it here, we choose this point, put it here. So those are good events. What's the bad event? Bad event is if we choose A, then we can't choose, for example, if we say this green point is I and this black point is I plus 1. Say if we choose I, then we can't choose I plus 1. So let's say, so bad event is we choose I and we again choose I plus 1. So that is a bad event. So definition, so there can be 11 n such kind of bad events. So we have A1 to AN bad events, and bad events means point I and I plus 1 are chosen. Okay, now what is the probability of AI, single bad event? So the probability of single bad event is, so let's say this is a bad event. So how many ways can this point I can be chosen? So there are so each color can have 11 points. So the probability of this bad event is probability of choosing this point, and this point is probability of choosing one point is 1 by 11, and probability of choosing another point is also 1 by 11. So it results in 1 to 1. So probability of the bad point is 1 by 1 to 1. Okay, now what is D? So D is how many bad events in which AI depends. So there is a definition of D. So AI depends on at most D bad events. So it means how many bad events AI depend on. So what is the D? So we have to find the D, and if you see this point, then how many such kind of bad events are there. And so there is I and there is I plus 1 pair. So if you see, then there are 2 pairs, and we know each color can have at most 11 points. So there are total of 22. For example, if we say A is green, and if we say I has color A, so say this has color A and this has color B, then there are 22 number of ways in which we can have A color. So this means if current event is AI, then there can be 22 different ways, but since we already choose this event AI, so there can be 22 minus 1, excluding the current bad event. There can be 21 other bad events in which involves this color A. And similarly, there is another 21 other events that involves B. So in total there are 42 such other events. Okay, now what we do is we put this value of D in this expression, and if we put value of D in this expression, then what we have is the expression is EPD plus 1, which gives you E into P is 1 by 1 to 1, and D is 42 plus 1, and it roughly gives you some value equals to 1 to 0.4 by 1 to 1, which is greater which is greater than 0. Yeah. No, sorry. So this is somewhat which is smaller than 1. So according to the Lovas Local Lemma, we should have this expression less or equal to 1, and we have this expression less than 1. This means the probability that this thing exists is greater than 0. So there is a probability that this thing will exist.